Okay, so let's do the rewrite on this one. So what's our base? We're raising that to a power of y, and that's going to equal x. Okay. So now we're going to do the same thing. We're going to sub in the y value. So we're going to take 3 to the negative 2 power, which is going to give us what? So basically, yeah, so it's 1 over 9, right? And it's 0.11? Is that what you got? Okay. Yeah, I think that's right. Okay. 3, we're going to raise that to the negative 1 power, so that's going to be what? 0.33, so that's 1 over the 3, so that's 0.33. Okay. 3 to the 0 power. 1. 3 to the first power. And 3 squared. 9. Okay, so let's graph that. So take a look at that. Take a look at the one we did the other day. How does it compare to the log base 2 of x? How is it going to compare to that log base 2 that we just graphed? How does this one look in accordance to it? What did you say, Lena? Yes. Yes, because we don't, so we can put that in. Yeah, so they do have, yes. Does he look a little more squashed? If you look at the values, in your previous table and you look at the values now, does he look to be compressed? He looks a little more squashed. So he is compressed. Thank you. Okay. So your log base, you had log base 2 and then you had log base 3. So as you continue to move up in your logs, you're going to see that you'll start seeing the higher your base is, you're going to be getting a little bit of a compression, okay? Because that's going to come in handy for you here in a little bit when we start graphing these. Your calculator, remember, graphs log of base 10, right? So if this is you've already looked at your base 2 and you've looked at your base 3, can you kind of imagine what log base 10 is going to look like? He's going to be really squished, okay? So when we graph these later, we're going to take that base 10 and we're just going to kind of stretch them in order to sketch, okay? Any questions on that? All right, we're going to move over to number 4, page 4. Okay, so now we're going to take our log function here, which is y equals log base 2 of x minus 3. We're going to do the same thing we did before. We're going to rewrite it. Okay, so our base again is what? 2. What's our power? Again, our power is y, and that equals, what was our answer? X minus 3. Okay. So we just rewrote it back into exponential form. Now we're going to solve this for x, just like we do inverses. This is basically doing our inverse, right? We switch the x and the y, and we solve for x. So if I'm going to move the x over, if I'm going to solve for x, I need to move or get rid of my 3. We're going to get rid of it by doing what? Adding it. So we're going to add 3 to both sides. So over here we would have the 2y plus 3, and then over here it's gone, so we just have our x. Right? Okay. Now we're going to come down here. We're going to fill in our table. You already have 2 to the y on your table on the front. Go back to that, and all you're going to do is you're going to take what you had and you're going to add 3 to it. So do that real quick. Okay, so the asymptote moved 3 to the right. So let's go ahead and put that in. We're going to dash that in. Okay. So that means we had a shift of 3 to the right. So we had a horizontal shift of 3 to the right. Okay. So notice what we had in parentheses, right? We had log base 2 of x minus 3. What's happening there? What is that 3? Is that our h, right? Our horizontal movement left and right. You see it? Okay. All right, now let's come down to number 6. So here's our function. We have y equals log base 2 of x plus 3. We're going to go ahead and move the 3 over to the other side first. So to get rid of it and move it, we're going to add it as a what? Negative 3, or we would subtract the 3 from both sides. So we're going to come over here, so we're going to have y minus the 3. That's going to be equal to our log base 2 of x. Now we're going to rewrite it. Our base again is what? 2. Our power is y minus 3. And that equals our exponent, which is what's our exponent? X. Yeah. Is that right? Okay, so let's fill out this table. So we put in a 1 for our y. 1 minus 3 would be negative 2. So you have 2 to the negative 2 power. We found that earlier to be 0.25. Now put in the 2 for the y. 2 minus 3 is negative 1. We found that 2 to the negative 1 earlier to be 0.5. Okay. Put in your 3 for y. 3 minus 3 is
0.
So 2 to the 0 power. Okay. Put in the 4 for the y. 4 minus 3 is 1. So that would give us 2. Put your 5 in. 5 minus 3 is 2. So 2 squared. 4. And then put in your 6. 6 minus 3. 3. So 2 to the third is 8. So let's graph that. Okay. So our pivotal point here at 1, 0 got moved up 3. So what is your 3 doing in your log function here? Vertically shifting it, right? So the 3 is in actuality our what? That is our k. Okay? Okay. So if we put that log base 10 in there and we graph it, we can see that, yes, in fact, he looks more compressed than that base 2. And also, does he look more compressed than the base 3 that we did, the second one we did? Yeah. Okay. So when you're graphing these, you can use your base 10 as a, just kind of to see the transformation, but you know that if it's a base other than 10, you just have to kind of stretch him up a little bit, okay? All right, let's go down to number 8, and you already have y1 in your calculator. Go ahead and put these in 2, 3, and 4. Y2, Y3, Y4. And sketch those out and see what's happening to that real quick, okay? Okay, so there is our parent. There's our Y2, our Y3, and our Y4. What happened to our Y4? Why is he below?
Negative is reflecting.
Yeah, that's a negative. So we reflected it over the x-axis, and we also did what to him? He's also been what? Compressed. See how close he is to the thing. So our 3 times log to the x, that was a stretch, but then our 5 times log to the x even stretched it even further, right? So what are the 3, 5, the 3, 5, and the 0.5? That's your what? What is that doing? That's your what? That's your A, right? And the negative is that reflection, which we would also consider the A. Okay? All right, so we have looked at our horizontal movement, right? The horizontal movement is very, very important on our logs because when we did that, I think, Preston, you said we got a new asymptote, right? So your horizontal movement is very important on this one because that does determine your new asymptote. And your K did what? It shifted up. What we did we go up 3 or down? We went up 3, didn't we? It shifted it up 3. Okay? So let's come down and summarize everything we've done. Okay, so here's our log function. Okay, if A is greater than 1, we're going to do what to it? Vertical stretch. If the A is between 0 and 1, we're going to do what? Vertical compression. If A is less than 0, anything less than 0 is a what number? Is a negative, which is a reflection. Over which axis? X. Okay. Our H. If we are subtracting the H, we're moving which direction? To the right. If we're adding H, we're moving to the left. And our K, if we're subtracting the K, we're moving down. If we're adding the K, we're moving up. Okay. And let's go back to that H. What did I just tell you? It determines what? Determines the new asymptote. The new asymptote. Now on our exponential, it was the K that was important, right? It was the K that determined your new asymptote. In this case, since they're inverses, it's the H that determines the asymptote. Any questions on those? We're going to practice them. Okay. We're going to establish what the transformation is. Log base 6 of x minus 1 minus 5. All right, x minus 1. X minus 1. Well, what are we gonna do with that? What is the transformation? Horizontal. Yes. So to the right one. Minus 5. Down 5. Okay. All right, so come over here to your graph. We know that when a parent is clean, we haven't done anything to it, it intersects the x-axis at that 1, 0, right? Now, we're going to move that pivotal point. We're going to move him to the right 1 and down 5. So move him to the right 1 and down 5. Where is he going to be at? No, move him over 1. He's already at 1, so if you move him over 1, 2, negative 5, right? So let's pinpoint him there. Okay, now let's get your calculator out. Okay, so let's graph that. Okay, so you can kind of see where your pivotal point has moved 1 and down 5. So here's your pivotal point. So how is that going to look? What's that going to look like when we graph it? So we've got that pivotal point at 2, negative 5. Asymptote. Do we have a new asymptote? Yes. Where is it at? It's at 1, right? Because we had x minus 1, we went to the right 1. So let's dash that in at 1. That's our new asymptote. We've got our pivotal point. We kind of have what it looks like as a base 10. We're going to sketch him in as a base 6. We're going to stretch him a little bit. So we're going to kind of give him a little bit more of a curve. And then he's going to come down next to that asymptote, right? Now, why is the calculator not showing this part of that? Why is it not showing that? Because it is there. Okay? The problem is your calculator starts blowing itself up when it gets close to that asymptote. It doesn't like it. So it just gets to a point where it says, I'm done, I'm not going to do it anymore. You, however, will need to draw it. Okay? You kind of think of the tail. Draw the tail and put the arrow on because you know that it is continuing into infinity. Okay? And same goes for up here, right? You need the arrow because you know it's continuing as well. Okay? So that's a sketch of a log base 6. We've moved to the right one, down 5. We moved our pivotal point, okay, to guide us. We can graph it as a log base 10 to kind of look at it. That's just to give you a look at what you're going to sketch, and then we'll sketch it in. Okay? Now I want to finish up by doing the domain and the range. Okay? So let's start off with the domain. What are all the possible x values for this particular function? X is greater than 1, right? Because in this case, since 1 is our asymptote, we never reach it, right? So it has to be greater than. What about our range? What are all our possibilities for y's? All of them, yes, right? All of them, because even though he increases slowly, he will increase to infinity, and he will continue to decrease next to that asymptote, right, into infinity. So our range will be all reals. Is the range going to be all reals no matter what our transformation is? What do you think, yes or no? Can you think of a time where our range is going to be restricted when we do these? Think about your homework. When you reflected it, would it have changed your range? Because if we reflected it, if we were up here and we reflected it, would it still have that same curve? Does our curve still go into infinity? Mm-hmm. What about over here? If we had a curve going like this, would that still be all y values? Yeah. So that is a pattern. Your range for logs will always be all reals. Your domain is going to be determined by your what again? Your asymptote, and your asymptote is determined by your h. Go back to your notes, okay, and add that to your h, okay? Your h determines the asymptote. Your h also determines your domain. So go back to your notes and put that in.